So in this lecture, we are going to discuss about the collision avoidance radar warning system, which is one of the very important safety related system we are observing in today's vehicle. So before going to start this collision avoidance radar system, let us have this one situation. Driving is a lot more complex than we typically consider when we get behind the wheel each day. But chances are he had a moment, a car that suddenly brakes in front of you, or an animal darting into the street, or a distraction that pulls your attention away, where you will find yourself suddenly in danger of collision. How do you react? Can you respond quick enough? Are some accidents simply unavoidable? So, road accident remains a major cause of fatalities globally. And as per statistics, 1.2 million deaths occurred due to the road accidents globally per day. Now, looking to this severity in India, every year in the first week of January, Ministry of Road Transport and Highways celebrates the Road Safety Week to make aware the public about this very hazardous situation as far as road accidents are considered. Now, when we look to these road accidents with respect to the vehicle, so vehicle safety is a key strategy issue used in addressing international as well as national road casualty reduction goals and targets. Every country is now thinking about this and they are framing the strategic plan as far as vehicle safety, road safety is considered. Vehicle safety addresses the safety of all road users and currently comprises measures for crash avoidance and injury prevention, which we are terming it as a primary safety, a reduction of injury in event of crash, that is the crash protection or secondary safety, and those which assist post-impact care, that is to reduce the consequences of injury. Now, if you see the holistic view of the safety, so this is the timeline from the state of the driver to the time of the crash or the particularly collision. Now here, if you see the state of the driver, when up to this particularly state of the situation, up to the dynamic, there will not be any conflict. But if you are in position that is driver unable to avoid cars, still able to control, that is by this particular position, driver is in position to make the car control in such a way that the collision can be avoided. So this particularly we are calling it as avoidance. Now here, this is the mitigation, wherein this particular distance, as far as time is considered, this particular distance where driver and car both are unable to avoid crash, and there is definitely the collision is going to take place, and due to that collision there will be the impact. So this is the imminent crash or collision, it gets happened here, and after that you are having the post crash. So we could not avoid this particularly collision, but after that collision, whatever the post crash which comes to reduce the severity to prepare to the crash. So when after this mitigation here, the driver and car need to prepare for crash, need to reduce the severity. So advanced driver assistance system, which we are calling ADAS. This ADAS is now very peculiar terminology. Frequently we are utilizing in automotive safety systems. So ADAS, Advanced Driver Assistance System, which we are defining as vehicle-based intelligent safety system, which could improve road safety in terms of crash avoidance, crash severity mitigation, and protection and post-crash phases. After crash occurs, what to do? This is also need to be taken care. Now, as far as ADAS is considered, this ADAS will have the different parameters, just like as the driving comfort, safety, traffic assistance, lateral motion control, longitudinal motion control, likewise. So as far as driver comfort is considered, we are having this adaptive cruise control, that is ACC, low speed adaptive cruise control, lane keeping adaptive cruise control, automated vehicle control, automatic parking system, glare free high beam, rain sensor. All these are the different systems coming under this driving comfort. Now if you consider the safety under this ADAS, then collision avoidance system, then external vehicle speed control, crash prevention, wrong way driving warning. These are the different systems coming under the safety. And as our title is collision avoidance radar system, warning radar system. So we are going to study in detail here. So traffic assistant will include the vehicle platooning. So what is the platooning? We are going to see later on. Then vehicle flow management, traffic jam dissipation, startup assist, vehicle to X communication, likewise. These are the systems coming under the traffic assistant. Lateral motion, lane departure warning, side collision avoidance, lane keeping assistant, blind spot monitoring, lane change assistant, emergency steering in intervention, crosswind stabilization, likewise. And last one, it is the longitudinal motion control, adaptive front AFL. We are already seen this particularly during vehicle lighting system, that is adaptive front lighting, night vision, safe gap advisory, deceleration assistance, active braking, torque control, rear collision avoidance, likewise. So here rear collision avoidance, which is the part of your safety, it is taken in the longitudinal motion control parameter. So these all are about the advanced driving assistance systems. And many of these systems, you will find many of the system that may be lane departure, side collision, then your this adaptive, then deceleration, acceleration. Many of these systems you are observing in new upcoming vehicles, which we are terming it as a automated driving systems. Now, as far as collision is considered, there are collision warning system or collision avoidance system. These are two systems. Though these seems to be same, this seems to be interchangeable, there is actually difference. So what is the difference between these two? Collision warning system and collision avoidance system. So in collision warning system, it uses GPS radar and or lasers to detect an impending collision and audibly warn the driver a crash is imminent. So in warning system, it warns the driver and it warns the driver audibly. That is related to your CWS, that is collision warning system. Then what is collision avoidance system? In collision avoidance system, that is the CAS, it takes this step further. It will not only warn the driver, but activate the brake or increase the speed or navigate the vehicle away from the danger. So it will actually activate the brakes or increase the speed, either accelerate or either decelerate, and or it navigates the vehicle away from the danger, that with the help of the steering, that the vehicle direction might get changed with the help of this collision avoidance. So first step is the collision warning system and next step is the collision avoidance system. So collision avoidance doesn't completely replace the driver. This CAS will not replace the driver but will actively assist in avoiding hazards in order to provide an extra layer of security. Now, collision avoidance system, which can be also known as a pre-crash system, forward collision warning system, or collision mitigation system, is an automobile system designed to prevent or reduce the severity of the collision. In its basic form, a forward collision warning system monitors a vehicle speed, the speed at which the speed of the vehicle in front of it, and the distance between the vehicle to provide a warning to the driver if the vehicle gets too close so as to avoid a crash. So the for collision system monitors the vehicle speed, the speed of the vehicle in front of it, and the distance between the vehicle. And by calculation of that particular distance and various speeds, we are going to see later on how these are affecting on warning. Various technologies and sensors are being used for this collision avoidance radar system that may include the radar, all-weather radar, or sometimes laser or lidar, and camera. Why camera is required? Which recognize the images to detect an imminent crash. So the vehicle which is in front of the our car should be recognized. So GPS sensors can detect fixed dangers such as approaching stop signs through a location database. Now, if we see the collision avoidance system evolution, we can see like this. So today we are having this cruise control, driver control systems. There will be no dynamics, throttle control with limited braking, then identifying stopped objects, low speed cruise and stop and go, enhanced ACC, partial all vehicle coverage, limited all vehicle coverage, complete 360 vehicle coverage. So these system functionality are increasing day by day. And in future, you will be having the functionality of complete 360 vehicle coverage with braking and steering to avoid object. And related to that, we are having the various systems. First, that was we were using the cruise control, then adaptive cruise control, enhanced adaptive cruise control, forward collision warning, collision intervention, collision avoidance. So now in upcoming vehicles, you will find this particularly collision avoidance as the compulsory fitment in vehicles. Now, collision avoidance radar warning system. It is anti-collision warning system. Use low power radar to sense objects and provide warnings of possible collisions. The radar antenna should be mounted on the front of the car and should project relatively narrow beam forward so that with the help of that camera or antenna, this particularly can identify the object in front of the car. Now, this CAS or collision avoidance radar system compares the time needed for microwave signal to be reflected from an object to the time needed for a signal to be reflected from the ground. By comparing this time with vehicle speed data, the computer can calculate time to impact value and sound an alarm if necessary. So this time to impact value, which is very, very important calculation as far as collision avoidance system is considered. So this is the pre-collision system, which is designed to prevent a collision first and then interact to prepare for collision if needed. So this is the in front vehicle. Now this vehicle is approaching towards this. Now if the distance is very less and this particularly within this particular distance, the alert is given to this particularly vehicle. That is, in coming few seconds, there will be the possibility of collision. So after getting this alarm, that is warning, suddenly the brakes gets applied. And if the brakes does not apply, then pre-collision system detects the possible collision. If the system is unable to prevent a collision, the system will perform the following action. Apply the brakes full force to reduce the vehicle speed as much as possible. Then close all windows and sunroof to prevent the occupant from being ejected from the vehicle, because whatever the occupants present in the car, they should not thrown away from the vehicle. Move the seats to an upright position. Raise the headrest if electrically powered. So this too indicates for firm that is sitting of the passengers or the drivers. Then pre-tension the seat belt. Seat belt gets tensioned so that the passenger or that particular driver gets firm seat. Airbags and seatbelt tensioner function as designed during the collision. This collision warning system can be looked in two ways. First, It is an aid to reversing, which gives the driver some indication as to how much space is behind the car when the reversing is taking place. And second, collision avoidance radar, that is radio detection and ranging, can be used as a vision enhancement system. Now, pre-collision system. The purpose and function of the pre-collision system is to monitor the road ahead and prepare to avoid collision and to protect the driver and passengers. This uses different components. First, long range and short range radar or a detection system used by the radar cruise control system to detect object in front of the vehicle. Another one, it should have the anti-lock brake system, ABS. It should have the adaptive cruise control, that is ACC. It should have the brake assist system. So this is particularly the various stages of the collision avoidance. So when sufficient distance is there, then warning sound will be given, and this warning sound will ask that apply the brakes. There is a possibility of the collision. Then after this warning sound, if brakes are not applied, then initially some brakes will be applied as long as you are getting this warning. Then if still you are not able to stop that and there is a possibility of collision, then secondary or auxiliary brake will apply so that the severity of the collision will get reduced. So this is the risk of the collision. System alerts driver with visual and audio warning. Brake assist will be activated quicker and driver presses the brake pedal. And this is the warning indicator alert. So on the dashboard unit, you will see the blinking of this brake. That indicates that apply the brake, apply the brake. Then automatically in serious risk of collision, FCM automatically applies moderate braking for encouraging the driver to take collision avoidance actions. So brake will be applied here. And once you are indicating that this particularly automatic application, so this will not show the automatic application of this brake. So this FCM automatically applies very serious risk of the collision wherein you are not in position to avoid the collision. Then it automatically applies emergency braking hard to help to reduce the severity of the collision if possible to avoid the collision. So here you are that is applying the auxiliary braking, and that indication you are getting in the instrument panel board, display board. So if there is no any vehicle ahead, then you are getting like this. You can have the ACC, that is adaptive cruise control, where the display area will show that this vehicle is moving, there is no any in front of your vehicle, no car is there, no obstacle is there, and you are going at the set speed of 100 km/h. So this is the indicator, shows ACC status, and this shows the intervehicular distance. So this particularly distance here, 480 km, or this is the distance between these two, between side and both the sides. So here, as with conventional cruise control, the vehicle maintains the speed set by the driver. That may be from 40 km/h to 100 km/h without requiring operation of the accelerometer. Then with vehicle ahead, this ACC, that is adaptive cruise control, follows the vehicle ahead at intervehicular distance set by the driver. ACC shows or stop the vehicle when the vehicle straight ahead slows or stops. So now this vehicle is moving. This vehicle is moving. This vehicle is moving towards this. Isn't it? So this vehicle will give the alarm. Now, what is the basic control flow for the collision avoidance system? You are having the wheel speed sensor and rear rate sensor, wherein with the help of this information, you are predicting the vehicle path. With the help of this radar system, with the help of this antenna and the image, camera, you are detecting the obstacle location with respect to the relative distance, relative speed, and direction angle. So with the help of this radar sensor, that is antenna, you are trying to locate the obstacle. Here with this sensor, you are trying to predict the vehicle path. Now with the help of this tool, you are calculating the lateral travel for collision avoidance by steering and evaluation of the possibility of rear end collision, and then you are giving the warning or actuation to the brake output. So this is the basic flow, basic control flow for this uh, collision avoidance system. Some commonly used names for this pre-collision or pre-catch systems are according to the various manufacturers. Ford Lincoln, this manufacturer gives this system name collision warning with brake support. Honda Acura, these manufacturers gives the collision mitigation brake system, that is CMBS. In case of Mercedes-Benz, they are calling it as a pre-save or attention assist. In case of Toyota Lexus, they are saying this as a pre-collision system, PCS, or advanced pre-collision system, APCS. So in general motor vehicles, it is called as a pre-collision systems. In Volvo cars, here it is called as a collision warning with brake support or collision warning with brake assist. So the names are different as per the different manufacturers, but whatever the basic fundamental working and whatever the components, that remains same. Now in collision avoidance system, this functions by monitoring objects in front of the vehicle and can act to avoid the collision by following actions. That is, it sounds an alarm and flashes a warning lamp. Just in earlier side we seen, that is brakes. It will blink the brakes. So applies the brakes and bring. Then after observing this flashing or by hearing the sound, the driver applies the brakes and brings the vehicle to full stop. If the driver does not react, then it gets automatically happen. Now this is the forward collision avoidance system, wherein you are, this is your vehicle, and this vehicle is now identifying this is the, in front of that vehicle there is an obstacle, another car is there. So with the help of this forward radar, this identifies this particular, locates this particularly obstacle and gives the visual warning. Now in merging collision avoidance, your vehicle is moving in this direction. Now the obstacle is not in front of that your vehicle, but obstacle is besides your vehicle, isn't it? So when obstacle is besides, then this merging lidar camera will sense this obstacle and it will give the visual warning which is there on the your driver's instrument panel board. So this is the forward collision and merging collision avoidance system. Now in forward collision, you are having this forward lidar which is fitted in front of the front bumper of your car. So there will be the sensor networking will be there, CPU bus memory will be there. Here for both sides, left and right, there will be the merging lidar to detect the side, that is obstacles. In left merging collision, warning indicator will be there. In right merging collision, there will be the again visual warning indicator will be there. And on this dashboard, you are having this. Here you will have the forward collision visual warning indicator. Here you will have the audible. Here you will have the vibrating steering wheel. Here you will have the off and on and off button, that is inside glove compartment. So according to the manufacturers, the instrument panel or dashboard may be designed accordingly. Now, if you are having this vehicle and host vehicle, this is the host vehicle, this is the driver, this is the non-vehicle obstacle, this is the other vehicle's obstacle. Now, this driver, that is alerting the driver with the help of this forward collision, alerting the driver by the merging collision. Then because of this, there will be the braking control, there will be the restricted steering, because we want to move the direction of your vehicle to avoid the collision. Then approaching another vehicle or non-vehicle obstacle. Then we may change the lane to avoid the collision and turning the system on and off. These are the interconnected systems from the non-vehicle obstacle to all these, from the driver to all these, to other vehicles to all this. Basic principle of radar ranging. Here you are having the target. From that target you are getting this antenna. So from this antenna you are having the transmitter and receiver. Transmitter and receiver. So this is the transmitter, this is the receiver. Distance is measured based upon the radar system. Radar system emitted outwardly to a sequence of contiguous millimeter wave or ultrasonic through the antenna, and the target is received a reflected signal measured using a millimeter wave and ultrasonic propagation medium. In the process, has encountered an obstacle occurs reflected advantage achieved between the vehicle and the vehicle measurement of the distance. So here, through this particular radar system, the reflected millimeter wave will go, this millimeter wave will go to the target, and from that target it gets reflected back and it gets received here. This radar generated by the transmitter the high frequency energy of certain form. Wow, our emitting antenna put energy radiation into the space. When wave travel in the space, when this wave, that is millimeter wave, travels in the space, it will receive, and when it is moving away from this antenna and coming towards the antenna, the wave travels in the space, then high frequency energy is reflected. Now this is the preceding vehicle, this is our vehicle. Now this is the preceding vehicle. In between that you are having this particularly distance. There are lateral obstacles of the to the both sides at the distance of L. Radar transmitter ultrasound or millimeter wave signals. The receiver receives the target echo signal. By measurement, the delay time between the transmitted wave and the echo signal to determine the distance between the radar and the target. And this is given by this. R is equal to Ct by 2, where R is the distance, that is the range. C is the electromagnetic wave propagation, that is velocity, air velocity, and T is the time. So here, this is the radar protected car. So here it is, there is a particularly radar sensor is there. So this sensor and this is the object. The distance between this sensor and this particular vehicle and object, we are terming it as a R, that is the range. The vehicle speed is V, and the speed at which the object is approaching, it is a S. So time required for to collision is 2 into C divided by 2 into R divided by C. The round trip time T from transmitter to object and back to receiver is proportional to range, that is R, vehicle speed, and C, that is the light speed of the light, which we are normally having the constant 186,000 miles per second. The radar system has the capability of accurately measuring this time to determine the range to the object. Now, the radar system can detect the object reflection and find R to determine the distance from the vehicle to object. In addition, the relative speed of the closure between the car and the object can be calculated by vehicle speed V from the ground reflected pulses and the speed of the object S, which can be determined from the change in speed object reflection pulses. If the object is traveling at the same speed, that is S is equal to V, that is Y, because Y minus because it is opposite, and T is the infinite, then collision would never occur. If the object is stationary, S is equal to 0, and time to collision is T is equal to R divided by V. Note that this system can give the vehicle speed which is applicable for anti-lock braking system. If the object is another moving car approaching the radar equipped with car heads on, the closing speed is the form of two car speeds. So here in this case T will be R divided by V plus S. So this is the schematic of your collision avoidance system, wherein you are getting this vehicle speed center and antenna scans tool is there. It will be given to the CPU. From that CPU, there will be the audible warning and visual warning. These are the outputs. So this is the input and this is the output. Now to this CPU, you are giving so many different inputs. So input is received from this antenna. You are having this local oscillator. There will be the mixture. Then there will be the difference frequency amplifier. There will be the pulse recovery. Then there will be the distance measurement, velocity measurement, interfacing filtering and time. And all this information is given to CPU. And from the same, that is the transmit antenna, this is the receiving antenna and this is the transmission antenna. So whatever the wheel speed, it is that is microwave oscillator and modulator will be given. That is from the CP, it is given to the timing, from the distance measurement, pulse generator, and then microwave oscillator and modulator. So inputs, output from the CPU, and again to the CPU, what are the input from this receiver antenna and what are the outputs from the transmitter antenna. Now this is the particularly figure shows the antenna which should be fitted, where it should be fitted. So ideally the antenna power system should be in as flat package as possible and should project a beam that has width of about 2 to 3 degree horizontally and about 4 to 5 degree vertically. So this is the vehicle which is moving toward this side. So here this is the reflection radar system. So this is the backward, that is vehicle is now reversing back. So when the reverse vehicle is reversing back, and it should be identify the obstacle while reversing. So from this particularly antenna, the reflected rays should be at 2 to 3 degree or 4 to 5 degree. Larger objects such as signs can reflect the radar beam, particularly on curves, and trigger a false alarm. There may be the possibility. This is one of the disadvantage of reversing mechanism. If the beam is scanned horizontally for a field degree, say 2.5 degree, either side of the center, false alarm from also roadside object can be reduced. For the collision warning system, better results can be obtained if the radar transmitter is operated in pulsed mode rather than in continuous wave mode. In this mode, the transmitter is switched on for a very short time and then it is switched off. During the off time, the receiver is set to receive a reflected signal, and if the reflecting object is in the path of transmitted microwave pulse, a corresponding pulse may be reflected to the receiver. So this is the schematic where you are getting. So these are the transmission and radiation, that is receiving and transmitting signals. So this is the radar sensors. This radar sensor gives the information to the processor. From the vehicle sensors like steering angle and braking speed, etc., you are getting the information. And from that, you are giving either auto brake actuation or the warning as like indicator to the brake warning, audio or visual. There are 5 possible states of the vehicle approaching to a stationary obstacle. So this is the vehicle approaching to this obstacle. So the vehicle and obstacle much different, that is distance is there. So this is the normal operation. If the distance is very less, and this is the when your vehicle is approaching in this, it reduces the distance, then within that particularly a collision is avoidable. But further, if this vehicle approaches nearer to this obstacle, this particularly range, we are calling it as a collision is unavoidable. Now there is obstacle, vehicle is approaching towards this obstacle. So this particularly region, we are calling it as a collision. And after collision, there is a post-collision. So there are 5 possible states: normal operation, collision avoidable, collision unavoidable, collision, and the post-collision. So there are so many car manufacturers which uses the various collision avoidance warning systems. So these are the manufacturers and these are the various collision avoidance technologies. So that may be the lane departure warning system, that may be the forward collision warning system, that may be adaptive cruise control, automatic braking, electronic stability control, because we want to make the vehicle stable. Then blind spot monitor, adaptive automotive night vision. So Nissan Motors, these vehicles are having this lane departure. This forward collision, you are not having any data here. Adaptive cruise control, these particularly types of the adaptive cruise control you are utilizing in this particular cars manufactured by this manufacturer. Further, you are getting Audi, General Motors, BMW, Volvo. So these are the car manufacturing using various collision avoidance warning systems. These are the Kia Motors latest, Fiat, Peugeot, wherein you are getting this electronic stability, ACS, ESP, likewise. So system is installed in forward collision warning system is installed, but the vehicle models have not been specified. So we are now taking one example of one of the CAS and what are the different components of one of the example which we are now going to discuss. This is the collision avoidance system, that is CAS construction. This is the vehicle. These are the different components. E-pretensioner, ECU is there. Yaw rate sensor is there. Anti-lock braking system unit is there. Millimeter wave radar is there. Steering display, warning display is there. Warning display is there in your steering display, warning display, and CAS switch. These are in driver's cabin in front of the driver. There is a CAS ECU in this particularly. Active wheel sensor is there. So there are so many different components. First component, that is the millimeter wave radar. It detects vehicles within a range about 100 meters ahead in a 16-degree arc. Another one, it is the sensors. In CAS, we are having so many different sensors. So this sensor system determines driving condition using a range of sensors. That may be the yaw rate, steering angle, wheel speed, brake pressure, etc. Then you are having this CAS electronic control unit. This is based on distance to vehicle ahead and relative speed obtained from the radar information and on the anticipated vehicle path as determined based on the sensor information. The ECU calculates the likelihood of a collision and warns the driver, and in some cases activates the braking function. The ECU exchanges information as required with the e-pretensioner variable signal analyzer VSA. There is a e-pretensioner ECU. It sends instruction to the motorized e-pretensioner to retract the seat belt. And this is based upon the braking instruction signals from central monitoring system ECU and electronically controlled brake assist signal. Next one, it is a e-pretensioner. Retract the seat belt using an internal motor based upon instructions from the e-pretensioner ECU used in combination with the conventional pretensioners. Then meter unit, which receives the signals from the CAS ECU and warns the driver of the potential danger using an audio alarm and the visual alarm. So this is another one conceptual architecture of collision avoidance system, wherein you are having the target vehicle tracking and host vehicle tracking, wherein you are having the side and rear sensors, forward radar sensor, forward vision system, GPS system, and in-vehicle sensors. All these are giving this information to the sensor fusion, where the data and sensor algorithm, data fusion algorithm and sensor will give the information to the target vehicle tracking and host vehicle tracking. This will have the in-path target identification and selection. Then after that, there will be the situational assessment, whether threat will be assessed or situation model will be assessed. And according to that, there will be the warning cues. The warning will be given as an audio or visual, haptic or tactic, or HUD, that is head of display, or one can give the active vehicle control that will actually activate the brakes, activate the throttle, actuate the engine. and that is steering. So these are the in-vehicle system driver monitoring. So this is again one of the another one way for representing the conceptual architecture of collision avoidance. This is another one vehicle mechanization of collision avoidance system, wherein you are observing here. This is the vision system. This is the forward radar sensor. This is the active vehicle control, that may be the brakes, steering, throttle, or transmission. This is the side detection center, that is that is merging cameras we are having. These are the vehicle sensors: GPS, map, inertia sensor. This is the radar detection sensor, that is rear world. Then this is the communication interface. This is the collision avoidance processor, which is connected with the help of this vision system, then radar, then whatever the active control systems, then side detection, then vehicle side interface. All these data you are supplying to the cab, that is collision avoidance processor. Now, in this, you are utilizing the visual warning, just like as a HUD, head-up display, instrumentation panel, or side and rear mirror. You can give the audio warning, that is voice or radio control, or maybe a tactile, that is seat vibrations, brake pulse, or steering wheel try to shake, or resistive steering likewise. So likewise, one can represent the mechanization of this control collision avoidance system. So this is, in short, the collision avoidance radar system, in which we have seen why this type of vehicle safety system is being used in the automotive sector. What are the different components of the vehicle collision avoidance system? What is the difference between collision warning system and collision avoidance system? What are the major components? What are the different sensors we are utilizing? How these sensors communicates the information to the uh, collision avoidance processors? Wow, what are the different country collision avoidance systems being used in various manufactured vehicles, manufacturers, which manufacturer uses which terminology? All these we have seen here. So here we end the discussion on this collision avoidance system.